Hi everybody, this is your last video in section 1 of unit 5. In this video, we're going to take a lot of the information that we've looked at in the past 3 videos and then represent all of that visually with Venn diagrams and tree diagrams. So let's go ahead and jump into it. Okay, you've probably seen Venn diagrams. I'm sure you've seen Venn diagrams before. Okay, it's just a visual way to display a sample space. Okay, so they can display counts within the sections, or they can display probabilities within the individual sections. Okay, they're most useful when a problem indicates that you have an intersection, like an and probability, between two categories. You'll see the word both very often, right? And then if you see a C, a complement, or a not probability, that shows up in the opposite, right, visual space than the original, right? So if we are going to shade these in, right? So you have a couple of visual probabilities here that I'm kind of showing you. Okay. And actually, I'm not going to be able to do this with a circle, so let's just do it with some shading here. So this first one here is probability of A, which just means everything in circle A, right? Probability of B is the same thing, but with event B, okay? The probability of not A is just everything in the space that is not within circle A, right? And same thing for not B, right? It's just anything that is not in circle B, right? So that includes outside of the circles, right, of the Venn diagram, and also within the part of circle A that's also not in circle B, okay? These visual representations, right, and these examples are not the only possible combinations of shading that you can have with Venn diagrams, but it covers a fair amount of them, right? So the bottom row here, this left one, is probability of not A and B, meaning that whatever you shade has to both be in circle B and can't be in circle A also. Okay, so you're shading every portion of circle B that is also not in circle A. Okay, the second one is not A or B. Okay, so that means you can shade in, hold on, you can shade in everything in circle B, right? Because that's one of your categories, one of your options. But then you can also shade in anything else that is not A, right? Because remember, or when you're talking about probability means falling in one category, B, the other category, not A, or falling in both of those categories, right? I'm not going to shade in the last two on here because you can see them visually on the left side of your screen, okay? But whenever the complement part is outside of a parentheses, what you do is you look at where you would shade without the complement notation. So like A or B is this area, right? It's all of the area inside the circles, right? And then you would just shade the opposite of that location, right? So anything else except that location, okay? Which is also what happened in this last one here, right? A and B is just this middle intersection portion. So if I'm going to shade this, I'm going to shade everything except that middle portion, okay? Right? A very typical thing that will be asked of you when talking about Venn diagrams is they'll ask you to take information in a two-way table and fill that in using a Venn diagram. Okay, so we have event A is the event male, and event B is pierced ears. Okay, so the intersection right, of the Venn diagram is the number of people or the probability of people that have this in common. Since they gave me counts in the two-way table, I don't really want to have to convert those to probabilities, and there's no real reason to, right? They give me counts, so I might as well use them. So if I want this intersection here, that's the people who are both male and have pierced ears, right? So that's these 19 people. Okay, in this kind of left crescent moon shape, that's all of the males that do not have pierced ears. So that's 71, right? On the other side is those who have pierced ears but are not male, so female, right? So that's the 84, right? And then you always have a number on the outside, which is the however many people or the probability of selecting someone that doesn't fit into either of these categories. Okay, all right. So I want to give you all a chance to try this one. This one deals with probabilities rather than counts, but it's exactly the same idea. Okay, so here we want to construct a Venn diagram for landlines versus cell phones, right? So those are your two categories, right? You can fill them in with probabilities rather than counts. So, for example, this 60% that have both, right, would be like 0.6. That would be the number that would be here in the middle where this 19 is with the counts, okay? One thing I want to point out to you when filling out and figuring out this Venn diagram is that these numbers, the 78% for landlines and the 80% for cell phones, is the whole circle, right? Would be the whole event, right? So if 60% have both, there's 60% in the middle, then that means only 20% would be in these like little half moon area, okay? So I want you to try out constructing this Venn diagram. Don't forget to put the rectangle around it to represent the sample space, right? In addition to the actual circles for the Venn diagram part, okay? And then see if you can calculate these two probabilities. So pause the video, try this one out, and then check back with me to see if you got the answer correct. All right, folks, go ahead and check your answers against mine. Okay, so there's my Venn diagram. You can see it in two places, on the left side of the screen and on the right side of the screen. Okay, so I have my two categories, landline and cell phone. It says in the prompt that 60% of people surveyed had both, so that goes in the middle. 80% total had cell phones, okay, meaning 60% in the middle means 20% in this little like half crescent moon shape here, so that you have 80% total in the cell circle. And then you have a similar idea for the landlines, right? 60% in the middle, and then 18% that's left over is in that little crescent half moon shape. Okay, now what we know is that everything inside of the rectangle, which is your sample space, has to add up to 1 or 100%, right? So right now we have 0.98%, not 0.98%, 0.98 inside the circles, right? Inside the actual Venn diagram, which is 0.18 plus 0.6 plus 0.2. So that means that we've got 2% or 0.02 outside of the circles. Okay. Question 2 says to find the probability that a household has a cell phone only, and that's this right crescent moon shape there. Okay, we're finding the probability that they have a cell but not a landline, which is just 0.2. Okay. And then number 3, there were a couple of different ways to find this, right? So this says probability of has at least one of the two types of phones, meaning they could have just a landline, just a cell phone, or both, right? So there's a couple of ways you can figure that out. You can either add everything inside the circles, which is that first thing that I did, or you can say, well, that's just 1 minus having none of those things, right? At least 1 is the same as 1 or 100% minus the probability of none. Okay, so that's this second way that I calculated this using the complement idea, right? 1 minus 0.02, and you get the same answer either way, which is kind of awesome. Okay, all right. So in the last part of this video here, I'm going to talk to you about multiplication rule and tree diagrams. So if you remember in the previous video when we were talking about independence, right? And you would be able to verify if certain events were independent if they, if you could multiply the probabilities of the individual events, right, and have it be equal to the intersection probability or the and probability of those two events, okay? What a tree diagram does is it helps us visualize that multiplication and help us visualize events that may happen in order, like in a sequence, you know, one after the other. Okay, so the multiplication rule states that for both of two events to occur, the first event occurs, right? So that's this, the general multiplication rule, probability of A. Then the second event must occur, given that we already knew the first one occurred. Okay, so what this is useful for, like I mentioned a minute ago, is when you have a series of events that are happening, and a tree diagram helps you visualize those series of events, right? So you start with your first event, which in my example here, we're tossing a coin, right? So my first event is the first toss of the coin, right? So when you're flipping a coin, you have two outcomes, right? Either heads or tails. So that's what this first branch is. As things fall on my desk. Okay, that's what this first branch is. It's just showing you the two options, right? Either heads or tails on the first toss. Okay, after the first toss, then you have two more options at your second toss, but that happens at each outcome, right? At each branch. So no matter what the first toss was, on the second toss, you have the same two options, right? So these events here in the second wave, essentially, right, or the second layer of branches is, for example, this event here is the probability of getting tails given, so this would be like second tails, given that the first event was also tails, right? This one is the probability that the second is tails, given that the first event was heads. Right? So essentially, what a tree diagram shows you is a visualization of this path that you could follow, right? And the more events you have, the more possible paths you have available to you, right? Okay. So my example here with the flipping the coin twice, right? We have this sample space. You can either get two heads, a head and a tail then a head, or two tails, right? So if I wanted to find what's the probability that I get two heads, right? What I can do is multiply along the branch, right? So follow the path and then multiply whatever the probabilities are along the branch, right? So the branch that I'm looking at is two heads. There's only one branch that gives me that outcome. It's this branch, the topmost one, right? So the probability of the first heads is 1/2. The probability of the second heads is also 1/2. So you multiply those probabilities together, right? That's what the multiplication rule says, in order to get that full probability, the probability of rolling two heads, which is 1/2 times 1/2 is 1/4. Okay. Now, if instead the problem had asked, what's the probability? Let's say the question had instead asked, I had to change my color here. What's the probability of getting at least one head? Right? Well, there's multiple paths that could lead to that, right? There's this path with two heads, so that's at least one head. There's this path where the first is a head and the second is a tail, okay? And there's this path, which is a tail first and then a head, right? So what I have here is 3 different paths, and I get 1/4 for each one, right? The probability is 1/4 for each one. So I would then have to add, right, all of those probabilities together. So I would end up with my total probability is 3/4. Okay. All right. So I'm going to do an example here for you that's a little bit more in depth and how you can see how these things may change depending on the choices that are made, right? So this example of a tree diagram is a tree diagram with independent events, right? The first toss of a coin is not going to affect the result of the next coin flip, right? But there are some times when, say, you're doing a problem where you're looking at a medical study or you're sampling with without replacement, right? Taking one person out of the population is going to affect the next round. Okay, so I have this two-way table here of females and males, and those that have allergies versus those that have no allergies. Okay, so this question says to draw a tree diagram that shows the sample space for selecting 2 students. So we're going to have 2 branches or 2 levels of our tree diagram. Okay, and it says determine the probabilities of their allergy status. Okay, so the tricky part about this is that they give this to you in a two-way table, but I only care about their allergy level. Right? I only care about allergy level. I don't care what gender these people are, right? The gender of the students, that doesn't matter to me, okay? So I'm going to start with my first person that I select, my first student. Oops. Hold on. Wrong thing there. Okay, so my first student, I have 2 options. That student can either have allergies or not have allergies, right? So what I'm going to do, just to make this a little easier when I'm drawing it here, but you can see the full thing written out on the left side of your screen, that I'm going to say A means allergies and N means no allergies. Okay, so here on my first branch, I have A on my top branch and N on my bottom branch. Okay, right? Then I have to look at my two-way table to figure out what those actual probabilities are. Okay, so the probability that I pull someone that has allergies is 18 out of 40. Because again, remember, I don't care about gender, I just care whether or not they have allergies. Okay, so and then there's 22 that don't have allergies. So the 22 out of 40 would be that probability there. Okay. Now I'm selecting 2 students, which means this first branch is my first student that I select, and I have to select another, right? Hold on. Let's try to actually connect those. Okay, so I have my 2 branches that will go off of each of my options for my first person, right? And we still have the same events, right? Either that second person that I choose has allergies or they don't have allergies, right? So this is A and N. And then same thing for this bottom one, A and N. Okay. Now, my probabilities are going to change slightly, right? Because I'm sampling people. And if I pull that first person, whoever they are, I don't want to then put them back in the population and sample them again, right? We don't want to do that. So what that means is that these probabilities in the second round are going to change. And we have to use the information from the first round in order to help us figure out what's going on, right? So just looking at the top part of this, if the first person I chose had allergies, and there were 18 of those people, then that means there's only 17 of them left to choose from in the second round. And then there's 39 people total left over, right? And then this number for no allergies is still 22, right? Because the first person I chose had allergies. So there's still 22 people left that have no allergies because I didn't choose somebody that didn't have allergies the first time, okay? Notice how at each branch, like each set of branches, each split, right, that the values that you have within each bunch add up to 1 or 100%. That should always be true, okay? Right? And it happens at every level, right? You notice it here on this first level as well, okay? Now let's fill in this second one, right? So if the person I chose at first had no allergies, and there were 22 of them originally, that means there's 21 of those people left out of 39 to choose from, okay? And then my number of people that had allergies didn't change because the first person I chose did not have allergies. So it's taking away from this total, the 22, without taking away from this total, the 18. Okay, and this could go on and on and on and on. You could build 3, 4, 5 levels of tree diagrams, right? Typically on the AP test, they won't go past 3 levels. And most of the time, really, your tree diagrams will look more like this, where it'll be 2 levels or 2 choices that you have to make. Okay, so question 2 here says, what's the probability that both students have allergies? There's only one path that I can follow that has both of those students that have allergies, which is this path here. So I'm going to use my multiplication rule to figure that out. So I'm finding the probability that both have allergies. So I'm just going to write this as AA, but I typed it out nicer on the left side of your screen, that both have allergies. Okay, it's that first probability, 18 over 40, times that second branch probability, 17 over 39. And when you actually do that math, you get 0.1962, okay? When we look at this in class, we're actually going to do an example that is a little bit more in-depth and shows you other ways that that free response questions especially will have you use tree diagrams and what a tool they can be when looking at and trying to decipher probability problems. Right? So that is it, you all. That's the last video in this section. So I will see you in the next video, which is the first video in section 2, where we're going to talk more about specifically random variables and then probability distributions, right? But now you have a really good solid foundation of all of the probability basics that will make the actual probability distributions a little bit easier to work with, right? So I will see you in the next video. Bye, everybody.